In this tutorial, we will see about shear strain is equal to summation of compression strain and extension strain. Already we are familiar with the shear strain. Basic concepts we have seen in one of the video tutorials initially. So you can go to the links, you will get in detail about it. Now we will see in detail. Suppose this is a cube which is being considered and force is applied along this edge DC. So whatever the changes takes place, that the shifting of D to D dash and C to C dash takes place. D changes to D dash, this is a D transform to D dash, C transform to C dash, and you are observing that this B, this is a point A, this BD is a diagonal, and this BD dash is a changed or transformed diagonal, or we can say compressed diagonal in this case. Here AC is the original diagonal, that is diagonal before applied force and diagonal after application of force, that is AC dash. So compression of diagonal BD takes place and extension of diagonal AC dash takes place when force is applied along this edge DC to one of the faces of the cubes is being considered, which is the front face of the cube is being considered. Now shear strain, that is angular change, takes place, that is a theta. So this edge goes to this edge goes in this manner and forms theta angle in this manner. So when we are considering equidistance, so this is the BF and this is BD dash, this is AC and E. So this EC dash is an extension, FD is an extension, takes place in this case. Now we will see how one of the faces to be considered for clarity, for sake of understanding. This D transform to D dash, C transform to C dash, and this angular displacement of this edge which having certain length L takes place. Similarly, so this AD goes to new edge AD dash, and this diagonal BD becomes BD dash. So compression of diagonal takes place, and this AC becomes new diagonal AC dash. So extension of diagonal takes place. So this is about the changes, transformation when application of force is there. Now you are observing how diagonal BD, which was originally observed in this diagram, this diagonal, this arrow shows this is the diagonal BD, and after the application of force, this compression of diagonal BD takes place, which is newly formed diagonal, which is BD dash, and this is diagonal BD dash after the application of force, after the transformation. Now see here, diagonal AC. This arrow indicates diagonal AC, this arrow shows diagonal AC dash. So AC dash is the extension of diagonal AC after the application of force, that is the external force along this edge DC. So D transforms to D dash, C transforms to C dash, and this angular shifting, this angular change, that is the shear, takes place. Now we will see when one of the faces of the cube shown in figure is ABCD, transform to AB, AB, C dash, D dash. After force F is applied, after this force F is applied along DC, due to applied force F, this applied force F, D transform to D dash, already I told you, and C transform to C dash. So diagonal BD, this diagonal BD compresses to BD dash, and diagonal AC extended to AC dash. So shear strain, that is the angular change, takes place, and that shear strain is equal to d dash, this d dash divided by this AD is equal to CC dash divided by this BC, this side. CE perpendicular to CE perpendicular to AC, then EC dash gives extension of AC. This EC dash is extension of this AC. CE perpendicular to AC, then AC dash gives extension of AC, and which is equal to AE, and DF gives compression of diagonal BD. Extension strain along AC, this extension strain along AC is given as EC dash. This EC dash divided by AE is equal to EC dash divided by AC. Both are equal. AC is equal to AE. So suppose this is equation 2. This equation we have considered 1. Angle C dash CB. See here. Angle C dash C and B is nearly equal to 90 degree. And angle C dash E is nearly equal to 45 degree. Then from triangle CEC dash, this CEC dash, EC dash, this EC dash divided by CC dash, which is equal to cos 45 degree, and that is EC dash is equal to CC dash into cos 45 degree is equal to CC dash divided by under root of 2. So this is suppose equation 3. Now from triangle ABC, this triangle A, B and C, this triangle BC divided by AC, this BC divided by AC, front side divided by hypotenuse sine 45 degree, which is equal to 1 by root 2. Therefore AC is equal to root 2 into BC. That is EC dash divided by AC is equal to CC dash divided by root 2 into under root 2 BC. Since CC dash divided by BC is equal to theta, therefore EC dash divided by AC is equal to 1/2 theta. Suppose this is equation 4. Similarly, compression strain along BD is decrease in length per unit original length, that is DF, this DF divided by BD, this BD is DF divided by DD dash is equal to cos 45 degree. DF is equal to DD dash into cos 45 degree, therefore DF is equal to DD dash divided by root 2. So from this, that is DF divided by BD, DF divided by DD, DF divided by BD and is equal to DD dash divided by root 2 into root 2 AD, and which is equal to 1/2 into DD dash divided by AD. Therefore DF divided by BD is equal to 1/2 theta. This is suppose equation 5. Since DD dash, this DD dash divided by AD, which is equal to theta. So therefore from equation 4 and 5, shear strain theta, which is equal to compression strain, which is 1/2 theta. Earlier we have seen it. Compression strain 1/2 theta plus extension strain, which is also 1/2 theta. So this is proved. That is shear strain theta shown in this diagram. This shear strain theta is equal to compression strain, that is 1/2 theta plus extension strain, that is 1/2